Hey guys, so you should have just watched two videos. One was a brain pop where they kind of talked about this idea of rational versus irrational numbers. And then the other one was a schmoop video, kind of a funny version of, again, addressing what makes something a rational number versus an irrational number. The main focus of what makes something irrational or rational numbers can be written as a ratio of two integers. So what that means is it can be written as a fraction, basically. If I can write it as a over b, it's a rational number. The other thing that makes a rational number rational, if you want to narrow it down, is that it's either a terminating or, which terminating means stopping, or a repeating decimal. If it's a stopping or a repeating decimal, we consider those to be rational numbers. The way I kind of remember it is we think about it like I can rationalize how that number ends. Either I can see where it ends or I know how it's going to end. If it's 0.3 repeating, it means that it's going to go on forever as 3, 3, 3, 3, 3. Whole numbers are what we started with. Those are our positive numbers, 0, and all of our positives. Integers are our positive and negative whole numbers. Okay. And then rational, of course, includes our fractions and decimals. And then the new part that we're adding on here is the irrational numbers. Irrationals are not terminating and non-repeating, meaning that they don't stop and they don't ever have a repeat, like a pattern that repeats. The most famous irrational number is, oh, it's up there. We'll put that in there in just a minute. All right, so if we put these numbers up here into their correct location, -6 would fall into the category of being an integer. Now, because it's an integer, it also falls inside the bigger part of our Venn diagram of being a rational number. 2.73 is going to be rational because it's a terminating decimal. 3/7 is also rational because it is a fraction. It can be written as a fraction. All right, now the square root of 2. Here's where we start to add in some of our irrational numbers that we've recently learned. Is the square root of 2 a perfect or a non-perfect root? So this is, again, where we're relying on you knowing your perfects. Now, I know the square root of 1 is 1, and the square root of 2, I don't know. But I know the next one up is the square root of 4 is 2. So the square root of 2 lies somewhere between 1 and 2. Anything that's a non-perfect root is going to fall into that category of being an irrational number. So the square root of 2 is going to fall inside here. Now the square root of 9, do we know that as a perfect? You should know that that's 3, which actually falls not only into being a rational number, but also an integer, also a whole number because, oh, that's 9. The square root of 9, when I evaluate it, is 3. -100 is not a whole number because it's not positive, but it does fall within our integers. 0 is a whole number. Pi is the most irrational or famous irrational number we know. 1 is a whole number. -1/2, again, it's a fraction, so that's going to go within our rational numbers. -3.8. Comma, that's supposed to be a point. 5.42 with the line over it. The line over it means it's a repetition of 42. So what that means is that number is going to be 5.4242424242 forever and ever and ever. Because I know how it's going to go on forever and ever and ever, we're going to put it inside our rationals. And then the last one, 8.293017 ... means I don't know what's coming up next. So that number is actually going to go in our irrational numbers. It doesn't have a repetition. The ... means it's going to go on further. That's what's going to make it irrational. All right, so now looking at the true false on the bottom of this page. All whole numbers are integers. Is that true or false? If you see the whole numbers fall into the set of integers, that is true. All integers are whole numbers. So everything in the integers category isn't necessarily a whole number. That's false because negatives do not go into our whole numbers. Some rational numbers are integers. So if they're rational, can they maybe be an integer? Absolutely. -6 is a good example of that. So that is true, especially since I said some. And then some whole numbers are irrational numbers. Can a whole number end up being an irrational number? Do you guys see how those Venn diagrams don't overlap at all? That means that would be false. They cannot possibly be both. Okay. Now, the irrational numbers and the rational numbers come together and they make up what we call the real numbers. Okay. They all come together to be real numbers, whether they're rational or irrational. All right, you guys, you're going to do some practice where you kind of put this thinking into play. Let me know if you have questions.